Hi folks, so now we'll take a look at number 3 from the October 4th lesson. Okay, so now we're still dealing with the first two problems that we were looking at, but now it says how long will it take for the account that was described in question 1 to be worth $1 million. Okay, so essentially now we're given the final amount of $1 million. Okay, and we have to determine how long that's going to take. So if I go back to my original model, okay, it's now the input value that I'm trying to solve for. Okay, so certainly I can divide both sides out by 5,000. Probably should do it in my head, but let's just be careful here. 1, 2, 3, 4, 5, 6 divided by 5,000. Okay, so we got 200 there. So this reduces to 200 equals 1.05 to the n. Okay. Problem is here, and this is, where again you would have run into a problem last year, is how does one solve, how does one isolate this variable here? Okay, now in grade 11 math, you would have been stuck, with the worst case scenario of trying to guess at this n value, and try to get as close as you can and keep checking values with your calculator. Certainly not the most efficient way of doing things. Okay, so some of you in chemistry or physics might have already seen how we solve this, but this is going to be one of the major tasks that we have in this unit. Okay, is how can we develop algebra to solve for a variable that's in the exponent. Okay, and we see that we're going to have a very similar problem here when we're dealing with the second one. So here I need my final amount of sodium-14 to be equal to 0.1. Okay. And let's say I use my second model, the more useful of the models, I would say. Again, if I try to start solving this by opposite operations at a certain point, how do I solve for that variable in the exponent? Okay, so this is going to be one of the major tasks again in this unit, is how do we solve an equation where the variable is in the exponent.